Yeah, hello guys, welcome back. Yeah. In this question, they just asked sort a given linked list. So the given input is an unsorted list, and we need to sort the linked list and return them the linked list, which is actually sorted. And this is the order after this is the output after we sort the given linked list, and yeah, this is the output. So how we can perform? We can use this merge sort by just first finding the middle element, and the middle element in this case for the given input is actually 8. So we'll first find the middle and then recursively call the left part and divide the left part. Then we'll find the middle one and we will divide it, and again we'll find the middle and we'll just do the same thing. It's just divide and conquer algorithm, and I'll show you directly code. It's just a straightforward approach, brother. Yeah, you can see this is the where the Leetcode solution actually starts. They'll just this is a given by default method, and I created the other methods. I'll show you that. So if head value equals null, or head dot next value is not equals null, if this is null, 45 is null, or 45 dot next value is equals to null, then return the head. It means they just if they give null or next only single value, return that value only. We don't need to do anything because there is not much to be done anything. So that is a base case, and then find the middle point, middle node. I wrote the comments, and this is where we find the mid, find middle of head, and here where is the function? We are actually doing function call here in this line, and where's the function middle? Yeah, here is the middle, finds middle, and we'll just pass a linked list here, and then we assign two pointers, slow and fast, which actually moves one slow moves a single time and fast moves two times. And based on that, we'll just use the base case for this one. We use fast because fast is actually moving two times. Fast is moving ahead of slow moves one time, fast moves two times. So we write the base case fast dot next value is not equals to null, and then fast dot next value is not equals to null. When this is the case, we actually need to break. Either one actually follows, then we don't enter this while loop. It means that's the end of, and we find the middle value. And we shouldn't do fast if fast value while fast is not equals to null, because that's actually the time when we are pointing at the null. We shouldn't point the null. So we should be aware, and we need to be ready that not making sure that fast dot text value is null. So to ensure that we are checking ahead, we are not using if fast value while fast value is not equals to, we are not doing like that. So that's the base case for this one, and we'll just move the slow by one and fast by two, and at the end, after this complete, after the fast reaches fast dot next value is not equals to null, or fast dot next value is not equals to null, when some either one condition satisfies, we won't enter this one. At that time, our slow pointer is actually pointing to the mid, and we found the mid. So where we'll return, actually we return who called us. This motherfucker called us, and we'll store the value of mid in the mid variable here. Sorry, we will just store the node at there, and the node is, in the case as I told you, the initially the node is 8, that is going to be stored in the mid, and then list node right equals to mid dot next. Means we are actually creating a new node named right, and that is actually mid dot next. It means mid is actually list node, as I told you, and dot next means nothing but we are just assigning the next value, which is 79, and storing it in the right, because we just need to divide and do that stuff, right? So to make sure not forgetting the next value, we're just storing here and we'll perform the operation. But I did a mistake by explaining that we'll do this thing, not about this one. Remember that. Sorry, it's my bad. We just first actually do first actually find some middle here, and then take our right pointer mid dot next into the right, and then mid dot next value equals to null. Mid dot next means 8 dot next, because this is a part and this is a part. We actually dividing. The whole question algorithm is based on divide and conquer. So we're just divided. So to divide that, we just added dot equals to null, mid dot next equals to null. And to not lose this point, we just added it to right list node kind of pointer that was pointing to this node. Yeah. Then what we are doing, divide the list into sub list using recursion. Yes. So sort list of head, we are just recursively calling the same thing by passing the different parameters. Here we pass head, which is actually the given linked list only. So we'll pass this as head, and we will do the same operation by dividing, and finally merging. So after dividing, at the end, we'll just only have the single values like this one. How we get, sorry, my bad. Yeah, see here. What the hell? Yeah, initially first in the first stage we just divided into this part, but when the but gradually we'll actually cut down into pieces and make it single element part. So these are single elements now. At the completion of this one, this is the resultant part, and then we just need to merge these parts, broken pieces. So let's fucking merge. Result merge left comma right. So we'll just pass 45 comma 12 initially, and then like this we'll just do this, and then merges finally, and then merges this, and then finally merges this part. So in this case we just merge this one, and this one, and these both are merged at here, and this is the final point, and we're done fucking merge. So I'll explain the merge stop. Where's the merge? Yes, list node left comma right. These are pointers, not pointers, kind of, yeah, pointers. 45 and 12 are, 45 is the left and 12 is the right. So we just need to merge slow equals to, it's not slow, it's actually finding middle one. So dummy equals to new list node. So we are actually having a dummy linked list, and we have the pointer current to the dummy, and then we are ensuring that left value is not equal to null, and then right value is not equal to null. Then only we will run the operation. And in this case, both are not actually null. They are actually values of 45 and 8, I guess. 45 is on point, but what is other? 45 and 12, right? So one is pointing to 45, other is pointing to 8. Sorry, 12. Right is pointing to 12. And we enter the while loop, and here 45 less than or equals to right value. Is that true? No. 45 is not less than right value. So we won't any, satisfy this condition. So this is wrong. So else is directly being executed. Current dot next equals to right. Current is actually a pointer of a dummy linked list node, and current dot next equals right. So dummy linked list node is actually something kind of 0, and 0 is pointing towards the right value. What is right value? Right value is actually 12, because 12 is less than 45. We add 12 and then increase the right pointer. Right pointer means in the original list, we just increment the pointer. What is the original list for this function? It's just two nodes. There is nothing there now, because right is actually 12 and left is 45. 12 dot next is actually nothing but a single linked list, so it is going to be null. So right dot next is going to be null, and we are at, as this line makes it null, and then what we'll do is current equals current dot next, because we are assuming that we are doing correct, but this actually makes it null, and current equals to current dot next. What is current value? Current is nothing but a pointer pointing to the dummy node, and from here we are moved to here, and our pointer is currently at 12, and then we'll just come from the top again, and we'll do this condition check. If left value is less than right value, is that true? No, because you can't actually access me, brother. Sorry, wait a minute. That's my bad. They're not coming if we just first come check the while condition, right? So is left value is not equal to null? Yes, that's true, because left is still 45, which is not equal to null. Yes, that's true. This is true. But what about this one? Right value is not equal to null. Right became from 12 to null because we actually access right dot next, which is currently pointing to null. So null value is not equals to null. Is that true? No, never. So this condition doesn't satisfy because of we are moving the pointer of right to the type 1. So we don't actually satisfy the condition. So while loop actually doesn't makes us in. So we'll come out of the value which is now which we are pointing now at here. If left value is not equal to null, is that true? Yes, left value is actually 45 and that is not equal to null, and we'll we satisfy this one. So we'll execute this part. Current dot next equals to left. Current dot what is current? Current is pointing towards 12. 12 dot next equals to left. Left is actually 45. So 45. And then we'll just return dummy dot next. To whom we'll return? First tell me what is dummy dot next. Dummy dot next is this part of the linked list, not the whole part. That's actually completely wrong thing. This only this part as I kind of circled it. So that part is actually represented by the return dummy dot next. So we'll return this 12 comma 45 to the person that was called us. Who is the guy that called us? Yeah, this guy. This guy called and we just return him, but we need to actually work with the more thing. So it's actually recursive, right? In the behind the scenes there's a call stack happening there. In a particular stack frame this call is being happened, but you just returning this one. Wait, yeah, but in that particular stack frame you're actually calling this function, but after completion you just return. But what what are you returning? You are returning to another call stack frame that is actually being called to the current stack frame. So from the current stack frame we will remove that from the stack and go back to the our parent who called us. So he says like, bro, you done that thing for me also, you can do this thing. So again we will do this call only for in the other stack frame. Then the values that are in that stack frame are 4 comma 99 this way, 4 comma 99, because 45 12 done and 12 comma 45 is the current linked list we received it here. And after finding this part we just merge these both, and again the same thing hierarchy will be happen, just nothing different, and the same thing happens. And it starts same as 0, the linked list starts same as here also 0. And then we'll check the condition while left value is not equal to true and right value is not equal to null. That's true. And left dot value is less than right dot value. Is that true? Is what are our values? What are our values? 4 comma 99, right? Left is actually 4, right is actually 99. So 4 less than 99. Yeah, that's true. So current dot next equals left. So left is actually 4. So added 4 here and left equals to left dot next. So in the original list, in the dummy list, the pointer is pointing left. Current as left, left is actually a pointer of 4, right? So 4 dot next is actually became 0 at here. So after 4, we just are passing the single digit nodes, right? So here it is going to be null. So now our left is actually null. Remember that thing, and then we increment. Then we'll move the current pointer by next. Then a current from here to here, where our current is actually pointing towards 4, and then we'll come here and we'll check the condition. If left while left value is not equal to null, is it true? No, because null is not equal to null is actually false, because null equals to null. That's true, but we are actually used the NOT gate, so we don't actually satisfy the case and it's being undone, so we don't need to check it all, because even you check also you don't enter that because you use the and condition. So you will get out the while loop and then check, is this true? No, this is not true, because while left value is not equal to null, is it true? No, because left value is actually null, so null is not equal to null, you are saying, but that's not true. So you won't enter if condition and you'll execute the else condition, which is current dot next equals to right. Current is actually 4 and Dot next makes us to point towards 22, I guess. I don't, sorry, it's 99. Yeah, 99. So we point to the 99 and just return dummy dot next. So dummy dot next is this part of the list and return to the parent that we are called by, and we return to him. He'll actually return to his parent, and his parent says, bro, my left part I got 8 and my right part I got 8, and I'll pass you one more thing and do that. Again, what we are doing is we got our left initially, now we got our right part, and we just need to now merge again these parts. What are these parts? These are these parts that we have actually done. These are these parts. 1245 is a one list and 4 comma 99 is the other list. This is left list and this is right list. Now we are passing these both at here. The parent who called in the another stack term. I can't show you. Maybe it's kind of complex to understand kind of stack because I haven't drawn the stack here. If I bring the stack thing here, it would be more beneficial, but it takes a lot of time. Yeah. So we'll pass one linked list and the other linked list here, and same thing happens, just nothing difference. We just actually check those values. Yeah, just this is the last try that I'm gonna do this now. So current out. So again, we will actually have a dummy linked list now, which is actually 0, and the pointer is current, which is pointing to the 0. And what we are doing, while left value is not equal to null, yes, that's true, and right value is also not equal to null, that's true. And if left dot value is less than right dot value, is that true? Left dot value, which is 12, is 12 less than 4? No, that's not true. So go to the else. Current dot next equals to right. Right is actually, what is the right? Current dot next, current dot next equals to right. That is actually 4, so point it to the 4. So we pointed to a pointer and move the right pointer. So from 4, we done this doing this one, and our pointer is at here. We're pointing to 19, and our left is our right, sorry, our right is pointing towards 99 because this is the right, this is the right list. As I told you, this is the right list, and current value is also being updated, and then current is going to be current equals to current dot next. So a pointer from 0 to 4 is being done, so we are pointing to 4 now. And then from top we are coming again, is left value is not equals to, no, that's not true, and that's not true, and we satisfied here, and right value is not equals to null. Is that true? Yes, that's satisfied, because right is actually pointing towards 99, not null. Null comes here, null is here, null is here. For both lists I'm saying, but that not satisfied. So we'll come here, left dot value is less than right dot value. Is that true? Is 12 less than 99? Yes, that's true. So do this one. Current dot next equals to left. Current dot next means 12. So current is actually 4 and point it to 12 and move a pointer to the 12. Which pointer? Left pointer is more. So 12 also being done, and we need to move this pointer to here. So current is also being done, and 45 comma 99 are the values that are being done. So we'll just do this one, 45 comma and then 99. So at the end, after repetitive things, we just return dummy dot next and exclude the 0, and we'll just return the whole part, and that's the end here. And where we'll return here. For this merge, we are returning the whole that currently computed value as left. But what about right? Right is being this part. Let me show you. Yeah, right is this part where we actually merges the same way the whole part, and finally merges the whole part, and that's the end, and we'll get this part. Yeah, that's it for this explanation. Yeah, it's quite complex, but you need to understand, it's time.